In this lesson, we'll conclude a review of Reading Test 8, Section 1. We are on the fifth and final passage. This is about the Venus flytrap. It requires a huge amount of energy to close its trap and to reopen it. And so this whole passage really, after explaining how the flytrap doesn't just close its trap indiscriminately, it needs the black hairs on their lobes to literally feel their prey. They act as triggers, and it has to be touched twice within 20 seconds. And the rest of the passage really gave the evidence. There were two different experiments as to what exactly causes this second trigger within an amount of time. And so we are on question number 47. According to the passage, which statement best explains why the Venus flytrap requires a second trigger hair to be touched within a short amount of time in order for its trap to close? And so we're just looking for evidence. And again, in the question choices, typically you don't have a paraphrase. In the answers, often you do, but we just want evidence as to why the flytrap requires a second trigger hair to be touched. So we're just looking for some evidence of that second trigger hair. And I'll show you where it is. I think it's just a good exercise, and especially with these types of questions, it's very common, but we're looking for that language, second trigger hair, and then looking for the explanation. And I'm going to start around line 50. They propose that the trap requires a relatively high concentration of calcium in order to close, and that a single action potential from just one trigger hair being touched does not reach this level. Therefore, a second hair needs to be stimulated to push the calcium concentration over this threshold. This is really the evidence. So in 50, the proposal says that one touch wouldn't reach the level because we need this high concentration. And therefore, that second hair touched within 20 seconds will push the calcium concentration over this threshold. All right, so let's take a look at the answers. The second trigger hair produces an electrical charge that reverses the charge produced by the first. Again, I think this was mentioned earlier in the experiment by Sievers and Hoddick, but this is not the reason why it needs that second trigger hair to be touched. The second trigger hair stabilizes the surge of calcium. No. The second trigger prompts the calcium channels to open. Again, this is not accurate. They're asking why it requires the second trigger hair. And we just read the second trigger hair provides a necessary supplement to the calcium concentration released by the first, right? That second trigger hair will push the concentration over the threshold. And so we need that extra surge, that supplement, to close it that after the second hair is touched. All right, let's take a look at question number 48. Which choice describes a scenario in which Hoddick and Sievers' model predicts that a Venus flytrap will not close? And so I read the end of that earlier in the beginning of this video. And so we see here, here's Hoddick and Sievers, and regarding how many hairs have been touched of its leaf, their model is quite elegant in its simplicity. They discovered that touching the trigger hair causes electrical action potential, a temporal reversal in the electrical polarity of a cell membrane. That induces the calcium channels to open. This coupling action potentials and the opening of calcium channels is similar to the processes that occur during communication between human neurons, thus causing a rapid increase in the concentration of calcium ions. And so we know that, just to review, and it was stated up here as well, that for the Venus flytrap to close, there needs to be two touches, right, within 20 seconds, right? And that will, because after, if too much inactivity passes, the calcium concentrations will diminish and it won't reach the threshold. So two touches, right, of the hairs on its lobes within 20 seconds, so it's a large enough bug for the trap to close for the prey. So we're trying to find which of the following would not make it close. All right, so if you look at a large insect's second contact with the plant's trigger hair results in total calcium ions concentration above the trap's threshold. This would cause it to close, right? The second contact, we read this in the previous sense, right? It pushes, it surges, it supplements the concentration over the threshold. Definitely would close. We want it not to close. A large insect makes contact with a second trigger hair after a period of inactivity. during which calcium concentrations have appreciably diminished. This is definitely the answer, right? If too much time passes, the calcium concentrations will diminish. It won't push it over the threshold on the resultant touch. And so the answer for 48 is definitely B. And let's take a look at 49. This is a word in context. What does demonstrate in line 67? We're just going to predict what demonstrate means here. So this is subsequent research model by Volkoff and his colleagues at the University of Alabama. They first demonstrated that it is indeed electricity that causes the Venus flytrap to close. So demonstrated, this is just proved, right? These are scientists. They have proven, and there's the experiment. So we're looking for proved. We don't see prove. It's not protested or performed or argued. Established. This means proved. All right, let's take a look at 50 and 51. This is a two-part question. Always scan down. And we want, based on the passage, what potential criticism might be made of Volkoff's testing of Haddock and Siever's model. And so what I would recommend is look for differences between. We know they both conducted experiments, but if there's some inconsistency, that might be potential for criticism. So we're just looking for differences. It's a very narrow range between 66 and 77. It's only 11 lines. So we're looking at Volkoff's experiment for some differences between his experiment and Haddock and Siever's. And so 66, this is in the beginning. We just read it. Demonstrated or proved that it's indeed electricity that causes the Venus flytrap to close. To test the model, they rigged up very fine electrodes and applied an electrical current to the open lobes of the trap. This made the trap close without any direct touch to its human hairs. While they didn't measure calcium levels, the current likely led to increases. And so this made the trap close without any direct touch. This is really the difference. We know that in Haddock and Siever's, the experiment is how many hairs have been touched, but they didn't even touch it. So that would probably be the criticism. That's the difference, right? And so it's probably going to be right here in 70, let's see, 71 to 74. And let's see if we can find the answer for 50 then. So we do have 71 to 74 right there. This experiment was done without the hairs ever being touched. Volkoff's understanding of Haddock's and Siever's models were incorrect. No evidence of that. Volkoff's measurement did not corroborate or prove or confirm a central claim of Haddock and Siever's model. This looks good, right? Because it didn't confirm. Haddock and Siever's touched it, and he applied the current without touching. This looks good. Volkoff's direct application of an electrical current would have been objectionable to Haddock and Siever's. Again, some students might find this tempting. We don't have evidence. We have no idea if they'd object. We just know it's different, and it didn't confirm the experiment because that Haddock and Siever's, because in Haddock and Siever's they touched it, but he didn't touch it, Volkoff. And so B is definitely better. We can't make this inference. And then Volkoff's technology was not available to Haddock. Again, we have no evidence of that. So it is B. And the final question, number 52. Based on the passage and studying the Venus flytrap, Volkoff and his colleagues made the most extensive use of which type of evidence? So how did they set up the experiment, Volkoff? So we'll just review. To test the model, they rigged up very fine electrodes and applied electrical current to the open lobes. And we read this before, no direct touch. When they modified this experiment by altering the amount of electrical current, they could determine the exact electrical charge needed for the trap to close. And so what they're doing is just applying this directly to the Venus flytrap. And so we're looking just for the method here. So let's take a look at the choices. Mathematical models to predict the electrical charge required to close the Venus flytrap. We have no evidence of models. That's not how they conducted the experiment. What use of evidence? Analysis of data collected from previous researchers' work involving the Venus flytrap's response to electricity. No, this is not how they conducted it. Even though there was a previous experiment, it was applied differently, and it wasn't based on analysis data. We're looking for how they conducted the experiment, what types of evidence. Information obtained from monitoring the Venus flytrap's response to varying amounts of electrical current. This looks good, right? They directly tested the flytrap and they applied the current even though they didn't touch, right, for monitoring the response. Published theories of scientists who developed earlier models, again, no. So the answer is C, and that concludes test 8.